Okay. So let's talk about hyperpolarization and depolarization.
Yeah, that's often very confusing, isn't it?
They sound very similar.
They do.
Okay, so here we've got like a membrane, and we've got some negative charges on the inside and some positive charges on the outside.
And where are those charges relative to the membrane surface?
These have to be really close to the membrane.
Why?
Well, as we talked about before, there's bulk electroneutrality, so these all have to cancel out with something.
So they're canceling out across the membrane,
yeah,
basically.
But we can just imagine that the something is all the way off here. And
right. But if they're really close to the membrane, they're actually canceling each other out across the membrane. If you just step back a little bit, that minus is kind of canceled by that plus.
Yeah.
But once they're floating out, then they're going to be neutralized by another floating ion that's hanging around.
Okay. So right now we've got this, and
so what would we call the membrane? What's the condition of the membrane if it's just sort of hanging out there, we're not doing anything to it? It's called the...
This is the resting potential.
Exactly.
So let's see. Neuron resting potential we can say is about negative 60. Right?
In millivolts, right.
So let's start with depolarization.
Sounds good. Do you want me to explain the idea?
Yes.
Okay. So you've got all this negative charge inside, and that's a polarization. If I take away those negative charges in some way, I could add positive charges on the inside, or I could add negative charges on the outside. I remove the negative charges inside, and the more of them I remove, the less polarization there is, so you call that depolarization.
Okay, so let's start off simple. Let's start just removing all of them.
Okay.
Right, so here we don't have any negatives or any positives. This looks very familiar.
Yeah, what would be a situation in which this would happen? Let's say you had concentrations of all the ions were equal on both sides.
Equilibrium.
And you have an equilibrium, and what would be the potential of that equilibrium?
Would this one be 0?
That's right. Now, in the real membrane, you will only pass through this very briefly, and you won't sit there because the concentrations aren't equal on the two sides.
Okay. So let's see, this is depolarization because there are less negative charges inside.
Yep.
Is how it works? Okay,
yep.
So let's say, let's do a little more complicated. Let's say we got rid of some, but not all. So let's, would this be like negative 30?
Yeah,
okay.
Right in between. And then, this is beautiful, what about the peak of the action potential? What happens to the polarization across the membrane there?
Well, there you're usually at like positive 30.
That's right. So what would the membrane look like?
Well,
in terms of the charges you just showed?
We'd have to have less negative charges on the inside. And for this one, less than 0 would mean negative charges on the outside?
Yeah.
Okay.
Yeah.
So that's right?
That's exactly right.
Okay, so this is, I'm going to draw a big arrow. This is depolarization.
That's right.
Because you're lessening the negative charge.
That's right. Reducing the polarization across the membrane, lessening the inside negative charge. And so, now we can go in the other way, right?
Yep. Okay. So hyperpolarization would be adding negative charge.
Yep.
Right? So let's go from 3, 4, 5, 6. So we're going to add these negative charges.
There's 1, 2, 3, 4.
There's 6 on each side.
Yeah,
yep.
Good.
It's difficult to count that many.
Yes.
Okay, so let's see. If we add negative charges, we're hyperpolarizing.
That's right.
And this would be what? Maybe negative 90?
Yeah.
Okay. So if we think about it as like sort of D negative and hyper-negative.
That's right. That's fine. That's a good way of thinking about it. And now, there are different ways of doing this. You could add positive charges inside to cancel out the negative charges, and that will take you in a depolarizing direction.
Because if we added like one positive charge here, these would neutralize, and we now only kind of have 3, and it would depolarize.
That's right.
Okay.
And then the other, if we add negative charges inside, that's going to move us in the hyperpolarizing direction.
Okay.
And we can even do things like change concentrations, which shift the Nernst potential, and that may move the membrane to a more negative potential or a more positive potential.
Okay. So, really quickly, let's say I add some positive ions outside the membrane.
Right.
So I'm just going to put 2 other pluses here.
Right.
Because of the sort of electrical gradient, that would put 2 more minuses here.
Exactly.
And this would change from what it was to maybe negative 120.
That's right.
Okay. So that makes a lot of sense.
It does.
Cool.